today at this time, I'm going to talk about the one project this group I'm leading. We received this year, so-called MASBio. We're focused on so-called Mid-Atlantic Sustainable Biomass for Value-added Products Consortium. It's a project-based consortium. So today I'm going to focus on outreach, demonstrations, and the potential product commercialization. And we only have a part of the product related to biochar, but I've tried to give you the overall view about this project today. So the MASBio is a regional consortium, as I mentioned in here. So we have on the team we have 6 different universities, and led by West Virginia University. I'm the PI, and with a few other universities like Virginia Tech, Penn State, SUNY ESF in the region, and also Wisconsin Medicine is part of this also. As you can see, Tina's group is also part of this Eastern Biochar Initiative, and with support from the National Biochar, U.S. Biochar Initiative also for this project. We're also working with some other industry partners. Total together, we have 12 industry partners on the project. At the same time, so we are working with 2 DOE labs and USDA for service and for products laboratory and so on. And our goal, we try to deliver the so-called sustainable and economically feasible biomass for value-added products system in the Mid-Atlantic region in the US. And of course, we try to promote our regional so-called bioeconomy in here. So we have 7 major objectives for this project, also the consortium. Number 1, we try to do something, pretty much try to demonstrate and identify and so-called some effective and cost-effective approaches for soil amendment, and especially focus on feedstock production and try to increase the feedstock yield. We're going to focus on several major energy crops, as I can mention a moment later. For example, like the switchgrass and hybrid willow and so on, in addition to logging residue stuff we are going to use. So number 2, pretty much focus on effective and efficient biomass harvesting and logistics. So any potential strategies, and try to optimize the whole entire supply chain of the so-called integrated biomass with residue together. So number 3, we do have a product conversion team. So within the consortium, we focus on several major bioproducts, including biochar. And our process, I don't have details today for you, but in the future, for example, we may have some detailed results. And I haven't mentioned to you, so this project started September this year, September 1st. We just finished our Q1. So our products, we are still working on this stuff, and we have some preliminary results. And I do hope, I believe, we're going to have a lot of results in the coming 5 years. So our process for the product conversion could be even we call it carbon neutral, and even sometimes carbon negative conversion as well. So we also will evaluate so-called sustainability and the human dimensions related or associated with the so-called product development, and also the proposed systems for bioproducts production in here. And the whole team will conduct so-called system and scale-up analysis. And we're going to use so-called robust artificial intelligence and big data-based data analytical methods in project. So the last 2 pieces for this consortium, we're going to focus on education and also outreach. So the education stuff, I have one slide for a little bit details, and we're going to focus on the education for the next generation the leaders for biomass and bioproducts in the country. And after reach program, we're going to work with a lot of industry partners and our regional stakeholders, and especially, for example, to promote the regional bioeconomic development through so-called integrated outreach programs we have developed in region in here. So those are the 7 major objectives we defined. So talk about our consortium collaborators and study sites. So this is the regional map we have. So you can see we're going to try to leverage and strategically utilize our available resources in the region. So including the lands, including the agriculture, marginal ag land, and also even the abandoned mine land and so on, more than 10 million acres in the region. And the region pretty much can produce more than 8 million dry tons of biomass, so for residue, for example, in here. And also the team so far has established more than 1,000 acres of energy crop sites already, and which had developed more than 20 new sites across the whole region. You can see the map and many different kinds of collaborators and partners on the map. So in Mid-Atlantic region in here. So that's John Wang showed a similar biomass supply chain a little bit before, and this is something we developed for the MASBio supply chain in here, and also say products. Today I'm trying to mention a few things to you, especially so that project we focus on switchgrass, willow, and forest residue. So following different kind of pathways, we can reach to this bioproducts part in here component, and the C-fuels, bioadhesives, and 3D printing resins, and nano materials, and wood vinegar, and the carbon products. So these are part of the things related to today's biochar initiative we are talking about today. So that's the whole supply chain, and you can see we have 6 major components in here, and with some details for each of the component. We have on-site and off-site processes, and even many different conversion pathways we're going to talk about a little bit. So before I start talk about potential products we have, I want to show you one slide shared by Dr. Tim Wolk and Mark SMBs with the SUNY ESF. So this team, SUNY's group is a part of this team, and they have been working on hybrid willow harvesting logistics for many years with the support from DOE and USDA. And this is something Mark shared with me a few weeks ago. And you can see harvesting a willow is very different compared to harvesting regular timber, for example. So they're using this kind of so-called one-pass and cut-to-chip harvester designed by Case New Holland. And they have been doing a lot of the so-called field demos and outreach activities and planting, and even some other kind of the outreach activities on their campus and in the state of New York. And now we're working on the willow harvesting with them. So for this project. So let's talk about some of the potential products we have so far, because as I said, it's a big project, and one of the 9 so-called CAP project funded by USDA NIFA, and we are going to produce 5 major products in here. So the first thing is we talk about bioadhesives in here. So that's the whole process in here. So our team as a member already received a patent, and we're going to further develop this patent from there to make so-called bioadhesive, so for potential, say, biocomposite, any bioproducts related potential uses for this adhesive. So that's so-called cross-linking and the dehydration process in here. You can see there's a so-called sour protein compound, and there's a lignin compound. And once we have this dehydration cross-linking, and you can see we can form many different kind of functional group, and with the linkage between soy protein and lignin together. So that whole things that make our, say, the adhesive very so-called green, renewable adhesive compared to traditional the adhesive used in the wood product industry at this moment. So this is something about potential resin could be produced from lignin-based stuff we have in here. It's so-called resins for 3D printing. And this is something by our team member, Dr. Steve Camley of Penn State. And he mentioned to me specifically, for example, when he presented this slide to the whole team, the MASBio team, for example. So his process with will use our the lignin produced from our conversion process, and with some kind of specific chemical treatment, and he can produce a so-called homogeneous resin for 3D printing. So that 3D printed product, so-called dog bone product, and pretty much based on biomass lignin, and could be able to have some kind of potential good market reason for that kind of product, and of course can produce some other related product from 3D printing, and based on the lignin we can produce from the conversion process. So that's things we talk about the CO2 conversion, and as we all know, for example, even say you produce a biochar using any kind of conversion unit, you will produce CO2, you will emit CO2. So our process, we can capture CO2, and we can reutilize CO2 for so-called nano-based, so bicarbonate products in here. So there's a whole process, and team member also received a patent also in the US, US patent. And you can see the process in here, for example, there's a conversion process we have. And once we receive the gas from the conversion, and even the biochar conversion process, we need to treat this gas stream, and with this reactor in here, so with specific so-called amino acid solvent with the CO2, we can produce both a CO2 lean phase and CO2 rich phase. The CO2 rich phase could be the product so-called soda, baking soda products already. So we have huge products in here. So that's pretty much the process we have in here. So the benefits for this unique process, as we discussed already, so includes, for example, something like this is kind of reduce the CO2 emission to the atmosphere, and the process is also energy efficient, very environmental friendly. So this is why I mentioned this whole our MASBio conversion process could be even CO2 negative, not only the neutral kind of conversion process. And also very cost effective, and could be very, it's kind of ready already for commercialization for this process, the whole things we have. So now let's talk about something for this National Biochar theme regarding biochar and carbon products in here. So we do have a few folks on the team also focused on the biochar carbon from biomass for some other applications. The biochar, for example, so the folks say at West Virginia University, and soil plant science, and even say Penn State folks, and several of our researchers and even say extension specialists have been working with our industry partners, especially to apply either wood or either some kind of say herbaceous biomass-based biochar for two major markets in the region. So including say industrial sorption application and even say nutrient retention and treatment application in the region. So led by Ed Johnston-Ball at Penn State. So we have a lot of potential on the field applications for the biochars. So carbon from biomass, so not only for this soil water improvement purpose, we can also make it so-called for other high-value products, like something I mentioned in here, a highly ordered mesoporous carbon for energy storage, like a battery, like the supercapacitor we have done in here. So this is something so-called supercapacitor application, and that charts here show you the so-called the capability of say so-called cycle stability of charging and discharging of this capacitor using biomass, and that's going to give you so-called the capacitance of this capacitor compared to others. So the biomass based in our study, for example, the capacitance could be reached to 70 F and G, and this is very, very comparable and competitive to other similar type of capacitor, and even better than a lot of bio-derived capacitor. So from our study so far we have, and my PhD student published this paper this year already. For that part, it is in the renewable energy for that purpose. And the other things, we can also use say char and the carbon for the water, especially the so-called flowback water purification, and from so-called shale gas drilling in West Virginia, Pennsylvania, Ohio area in here, So we have a lot of shale gas drilling activities ongoing, and generate a lot of so-called flowback water. So the issue is we have to reutilize this water, But how can we utilize the water? And this is so-called flowback water. We need to purify some of the major contents in here, And those say flowback water pretty much contain a lot of different things in here, including metal ions and barium, strontium, and calcium, iron, and so on, and even including organic matters, for example, benzene, oil, grease, and so on. So those kind of things. So over the years, we also do some study regarding how to purify some of the elements. So that chart in here, for example, just try to show everybody in here. We make some comparison. If we use regular char, biochar, and compare to two different types of activity by carbon, for example, and biochar carbon, they can both remove and purify the metal elements from the water to some level. But activity char carbon, of course, could even do some better, in terms of the barium removal from the flowback water. So this is something we found out, and some other researchers also focus on some other elements removal to meet the requirements for reuse flowback water back to the drilling process for the shale gas. So talk about the potential biomass demonstration and potential commercialization cases we're going to do in the coming years. So far, we haven't finished anything yet because we just finished our first quarter. And we're going to have the so-called 5 major cases in here. Talk about the hybrid willow production and harvesting, and herbaceous biomass production and harvest, and the forest logging residue logistics demo and utilization, and the products including say bioadhesive, biochemicals, and biochar and stuff, especially the last row, in that table. And we're going to work with quite a few different say, regional partners and researchers, and quite a few folks have reached to me and other team members talk about potential say, outreach, collaborations, demonstrations, and even potential commercializations. And this is, as I said, one of the 9 CAP projects funded by NIFA. So each of 9 groups received $10 million for 5 years, 5 years. And that's the only project, from among the 9 projects funded this year by USDA, only focus on potential ag and forest biomass for potential value-added products. So other groups, they focus on food and water and some other related topics. So regarding potential outreach and commercialization activities, and something related to so-called extension stuff in here. We're going to do something with industry partner together, for example, for all the potential efforts. And as I mentioned, we have 12 partners. And the team will work with our stakeholders, focus on so-called social economic impacts of the regional economic development. And we have the team members working with the business schools among universities in the region. So we're going to do some kind of market study. So also develop some kind of business plans for the regional biomass, not only for biochar and potential other bioproducts also. And we are going to find out what are the potential market opportunities for those potential bioproducts in the region, and even could be reach out to other regions as well. And this group, we talked to Tina Messer's group already, and we will work together on another component called the workforce development in the region. So we need to educate folks and potential work to educate these people and to work for them to work in this sector, biomass for bioproduct sector in the future. So this is why we have this so-called outreach commercialization education component we have in here. So among these 5-6 different universities in here, so we are going to have undergraduate scholars program. So those scholars are going to rotate among those 5-6 different universities and reach out to the researchers, developers, and other stakeholders and focus on and related research topic. And they're going to see a lot of different things for them. And undergrad student also see courses, and even see we're going to have so-called design courses for competition among them for the bioproduct design and seminar in the biorenewables among these universities. And we're going to have so-called minor certificate programs for our partner universities also on consortium in here. So the last piece also very important. So that's a project consortium. We will reach out to the primary and secondary educators as well to educate them. So the research and our outreach programs and so on. So this is something we have for potential education. And again and again, so once we are making progress and we're going to reach out to the public and to other stakeholders and so on. So it means that we're going to disseminate our technology, any major findings and so on through a lot of different so-called social media channels, and we have a major website and so-called MASBio.wvu.edu, and we're going to share our data with a lot of different partners like 2 DOE national laboratories and the USDA USB life cycle, data commons, and so on. And this is my last slide, and have my information there. And if for some of you like to talk to me for further information, and you can write down my email, and you can send something to me. Hi, everybody. Again, thank you very much, everybody. And that's about it for the MASBio.